Why do tiny tweaks unlock huge AI scaling performance? Imagine trying to fill a giant bucket with water. Sometimes, just adjusting the tap slightly can make the water flow faster and fill the bucket quicker. That's similar to how small changes in artificial intelligence systems can lead to big improvements when scaling. When we talk about scaling AI, it means making models bigger, using more data, or adding more computing power. But simply adding hardware often hits a wall where more effort doesn't mean better results. Tiny tweaks can fix this problem by making the system work smarter, not just harder. One reason small adjustments matter so much is because of algorithmic efficiency. For example, tuning hyperparameters, which are settings that control how a model learns, can make a big difference. Removing unnecessary neural network connections, called pruning, helps the model run faster. Reducing numerical precision, known as quantization, cuts down on the amount of data the model needs to process. Transferring knowledge from large models to smaller ones, called knowledge distillation, allows smaller models to perform almost as well as bigger ones but with less computation. Another key factor is resource allocation. Fine-tuning how the computer's central processing units, graphics processing units, memory, and storage are used ensures they operate at their best. For example, directing processing power to the most complex parts of a task can speed things up without adding more hardware. This kind of smart resource use allows AI systems to grow efficiently and handle larger workloads. Software tools also play a big role. Using optimized frameworks like TensorFlow or PyTorch helps models run smoothly across multiple computers. Managing workload distribution and load balancing with tools like Kubernetes makes scaling from one machine to hundreds easier. Data management is another piece of the puzzle. Caching results means storing frequent outputs close to where they are needed, reducing redundant calculations. Efficient data preprocessing and tiered storage help handle massive datasets faster, which is vital when scaling AI solutions. Finally, breaking down tasks into smaller steps with intermediate checks helps catch errors early. Adaptive inference, which adjusts how a model reasons based on the situation, makes the process more efficient. Look at ChatGPT, DALL-E, and Midjourney. ChatGPT uses pruning and quantization to generate text quickly on existing hardware. DALL-E and Midjourney optimize their models and use caching to produce detailed images efficiently. Productivity plugins also help by simplifying inputs before processing, saving resources and making responses faster. In the end, tiny tweaks improve how models and systems work together. They make AI faster, more efficient, and capable of handling bigger challenges without needing huge jumps in hardware. This approach is key for businesses and society to get the most out of AI as it grows.